Welcome, everybody. I hope that worked. We're adding new buttons, new switches every week to the show, trying to get real fancy pants on you. In fact, I'm wearing pants, probably one of the first time I've worn jeans since the summer. So yeah, it's a brisk 70 degrees here today. So I figured pants were probably in order. Welcome to Tanzu Tuesday. We did it. We're here. It's just Tanzu Tuesday. There's nothing else happening today on this Tuesday.
At this time.
Just at this time. It's just a regular Tuesday with regular people talking Rabbitmq. It's great. It's wonderful. Thank you so much for being here. And as always, Paul, Tiffany, thank you for joining. How are you?
Good. It's
wonderful.
Definitely not 70 degrees here.
Oh, well, I'm sorry to hear that. Paul, what about you? How warm and delightful is it in Austin?
It was chilly this morning, but it has started to warm up as the sun came out. I actually went for a sneaky fish this morning, so I took my kayak out on the river and did a couple of miles, caught a couple of fish, and then got back in time for this. Although we just kicked off daylight savings, or we turned it off. I can't remember which way it went.
Right,
but it meant
an hour.
that I no longer get up before the sun comes up for fishing, so I need to start waking up an hour earlier, which is not cool.
No, they didn't ask about that. That's not cool.
Yeah.
Your sideburns are gone. Your chops.
That's right.
Chops. You're moving back into your pirate beard phase.
Yeah, I don't know what I'll do, but I'm usually how lazy I am dictates what my face looks like.
And are you celebrating the month of November as well, or it just all happens to be at the same time?
It all happens to be at the same time.
Got it. All right. Well, let's welcome our guest, Gerhard. Hello, Gerhard. How are you?
Hi, Bob. I'm good, thank you. Enjoying a good tea, as you do at 9 p.m.
Right. Where are you joining us from?
I'm based in the UK,
okay,
just a little bit north of London, so that's like a good reference point.
Always a good reference point.
Talking about the weather, it was the first day when I went for a jog and I had to put my long pants on. So that's how I know that autumn is coming.
Yes, exactly.
It was still sunny, but chilly. It was really chilly outside.
Yeah, and it kind of tends to get a little chillier in those parts of the world than California or Texas. Seattle, I would say, probably has an akin.
It's 51/11 right now.
What's the 40-degree difference in? Or are you saying 11 like as in C?
11 for me. Thank you.
Okay,
because 50 doesn't mean anything to me.
Right, okay. I thought you were like highs of 51, lows at 11 at the same time. Yes, nope. 11C.
The person who would get it got it, so that's all that matters. It's fine, Bob. Fine.
I feel included. Well, thank you.
Yeah, I don't know if you are familiar with the product marketing team, but Phil Ray, who lives outside of London as well, he's a big runner as well, so I'll have to ask him if he's putting on his long pants to go on his runs as well. He's one of those crazy ones that like runs for 100 miles and then stops. And, I go, okay, that's good. I've done a half marathon. I call myself half crazy. And I've never at the end of that half marathon gone, let's do that again. Let's just run it back and just do the whole thing. So, but hats off to all the runners and people that are choosing their exercising, whatever it is, do it. Get out.
Yeah, not me.
Yourself.
I can't.
Yeah. But, well, great. Well, we are so happy to have you. We're going to be talking Rabbitmq. Before we get to that, let's obviously do our little announcements. We've got some great stuff coming up 2 weeks from Wednesday, November 18th and 19th. We're going to talk about Win a Spring Testing Trophy. So we're talking about spring testing, in particular, the testing trophy does like high-level integration tests, introduces static and analysis as the base. And we've got Belabai and Alexei Nestorov going to join for the 2 days. So the first day will be the 2-hour session where they're talking about it. And then the next day will be an hour Q&A, fireside chat, whatever you want to call it. So register now, spring1tour.io. Again, that's November 18th, 19th. Free to register. But you need to register, especially if you want to be a part of the Q&As and do those kind of things. Otherwise, you can just watch it on our Twitch channel, which we stream it live. We stream a lot of our other things live. If you just can't ask questions, you're not kind of part of the other process of it. But
You
again,
can ask questions. They just won't get answered.
Sure. Yes, you can always ask questions. It's if you want those answers is up to you. So we leave that up to you in your capable hands. Tomorrow, in fact, is another great Spring coding session with Josh Long. It's a rom-com with Spring and Kubernetes. So definitely tune into that. That's 1 p.m. Pacific time tomorrow with the Josh Long experience. Hold on. I got it. There it is.
Start.spring.io.
Start.spring.io.
It should be 12.
12? Oh, is it 12?
Unless I screwed up uploading it.
No, I just always thought it was at 1. So that could be me.
It's just
it is 12.
Okay.
Strike that, 12 p.m. Pacific, Josh Long, Spring and Kubernetes. And then also later this month, November 17th through the 20th, is North American Virtual KubeCon. KubeCon is an incredible experience worldwide. There's usually one in Europe and one in the US. We're not going to talk about the one in Europe that was supposed to happen this year because then we will get derailed by Tiffany talking about how she was going to go on vacation. And it was a week after she started the job, and she was going to take her dad and then her mom, and they were all going to be there, and her fiance, and they're going to go to the Netherlands. And
actually, his parents, not mine, but
Okay, well, whatever. Anyway.
I wasn't going there, okay? Thank you for telling my story for me.
I know, I was trying to be silly.
Thanks.
You're welcome. Mm-hmm. You're welcome. But anyway, this one is virtual and in the North American time zones. Last year was in San Diego, which San Diego is always a fun time. So sadly, not this year. But yes, go to events.linuxfoundation.org and you can register there. And as always, you can go to our Tanzu.tv channel, check out all our different content. We have past, present, and future. Like next week's show for us, we've got the Josh Cummings coming on, talking about Spring Security and OAuth 2.0. Josh is a regular on our Spring One tour that we normally do. And so he's going to be talking Spring Security next week, which would be great. And we have lots of other future shows, as well as Mondays between the keyboard and the chair with Nate Shuda. And most mornings, 10 a.m. Central European time, our good friend Cote has his video blog, which is just always fun and great to hear him.
He's really getting on with his video production quality. He's doing some weird like green screen things, and he's really enjoying himself.
Yeah, it's fun to watch that evolution. And Java Grunt, yes, welcome. Thank you to Sean. Hello to you, sir. Many happy returns. Happy regular Tuesday to you. Just a normal Tuesday here. Nothing else happening besides this wonderful show. And so excited to have you watching. And I think with that, let's get on to Gerhard. So you're broadcasting from north of London, the UK. We talked a little bit before the show that you are you've got a German first name, a Polish last name. You were born in Romania, is that right?
Yeah, that's right.
But your family is more Slovakian than anything, so you're kind of just this great European mutt, and I love it.
It's a good combination. That's how I describe it. It's a good combination. Yeah. It allows me to appreciate many things in different ways, which I enjoyed very much.
Well, and you get the strong opinions of the older generations of the family, each side of the family, but then you're like, hey, I'm mixing it all together, and so that's wonderful. Now, how long have you been working on? When did you get into developing in just kind of the IT world? What kind of started your interests?
So true story, but funny story. I didn't.
Good. We don't want any fake stories here.
Okay, only real. True. Only true stories. Okay. I wanted to get out of French classes, so I had to pick up programming because I didn't like to learn French. Yeah. So I would build websites. That was 20 plus years ago, and a passion became the main thing, like a job. It was my happiest day when I realized I could get paid. Right. For something that I'll do for free, happily, all day, every day. So yeah, it all started front end, back end, and I got to appreciate, as I say, many different areas. Rabbitmq for the last 4 years, 5 years, I don't know. I kind of lost track of time. It's all relative, I suppose. But yeah, Rabbitmq has been home for many years now. I like it very much. And some good things are coming.
And in rabbit years, that's like 20 years. So you've definitely been doing it.
In rabbit years, it's definitely 20 years, yes.
I like how you traded a language for different languages.
Right, for a different language, basically, yeah.
True. Yeah. I remember writing HTML by hand because I didn't have a computer. So that's how I learned HTML without a computer. CSS wasn't a thing. People thought I was crazy for getting into CSS. It didn't exist at the time. And JavaScript was like, what is this thing? Like, yeah, it was fun days. So yeah, language.
JavaScript is still like that, to be honest, for me at least.
It is, right? It is. So yeah, like multiple languages feel natural to me in more than one way.
Well, that's awesome, and we're obviously so happy to have you here. You said you were a runner. What other kind of fun exercise, or just things do you like to do in your spare times?
Mm-hmm. So I enjoy making coffee, which is a weird thing to say, but actually it takes me longer to make coffee. Good. Yeah. So it takes me longer to make it than drink it.
Right. I think that's how you're doing it properly. Yes.
Mm-hmm. Mm-hmm.
So what is your go-to preparation technique?
My go-to preparation technique. Switch the machine on. It needs half an hour to warm up because it's a proper one. So set up a timer, right? Automatic timer, schedule on and off so that 6:30, it switches automatically on. So by the time I wake up, it's already on, nicely warmed up. So that's the preparation. It begins way before. The beans, very important. You need to know where to buy them from. There's like a very short shelf life, always freshly roasted. You have maybe about 10 days to use them, right? So you always get a fresh batch. Know where to keep them. Experiment heavily with the right grind size. And once it's adjusted, typically only when you change the beans, that's when you have to do the small tweaks. A few scales around to make sure there's always 18 grams, right, in the portafilter, very precise. And you need to do like the first flush of the machine, right? Because you get the, I forget what it's called, splurge or something like that. So the first water coming out of the portafilter will always be, or like the coffee head, the brew head will always be super hot, gushy. I think a gusher you call it. So do that first. Make sure the coffee head is properly primed. And then just continue. I think people are bored by now, so maybe I'll stop talking.
Hey, look, I'm coming to Gerhard's cafe when I'm in London next. Sounds great.
Sure. I have a picture to share.
Yeah, our team basically travels to drink coffee, essentially. It's we also do develop other talks, but it's more for food and coffee. So yeah, you're talking to the right people. But well, that's great. So coffee, that sounds like between coffee and running and working, that's about all the free time you have if you're going to devote that kind of stuff to coffee, which is great. Something you said made me think of, I can't remember, I'm blanking on it, but it's all right. I'll remember mid-talk and then I'll just blurt it out in the middle of whatever you're talking about and just derail the whole conversation. I hope that's fine.
Of course.
Well, thank you again for joining us and staying up late. I hope that your tea will keep you up. We're thankful for everybody who's watching. Again, Deshaun, so great to have you back on, and all of our viewers. And without further ado, let's get on to the Rabbitmq with Gerhard Lazu.
Nice rhyming. Further ado, Rabbitmq.
I mean, Gerhard Lazu. I mean, it's a thing. It's a thing.
All right, let's get the show started. Share screen. Does that work all right? How small is that?
Very small.
That's very small.
Tiny.
Okay. Let's bump it up. So let's go to profiles. It will mess with a few things, but that's okay. We can make it work. That's the present profile, text size. So that was 16. Oh, I see why that's too small. Okay. Let's keep it there for now. So if I do this, how does that look? Still tiny?
I think it's readable, yeah.
Okay.
Unless people have it in a tiny little window, I think it's probably good.
That still sounds tiny to me. So let's crank this up even further. Let's go to default.
Deshaun says almost readable.
Almost readable. Okay, that's not good. We want it to be fully readable.
Yeah, all the way.
So how about that? I'll list some files. Still small?
It changed.
Okay. I get it. Okay. Slide the zoom bar over, all the way over. All right. Okay. I can give you 20. I can't give you any more than that. That's it. 20.
Wow, that's looking better, I think.
Okay,
Wait,
hang on.
no.
We're not there. No, we're not there yet. Okay. So let's do that. Okay. And if it's still small?
I think that's better.
You're killing me. Okay.
Well, I have my
I'm only
window
laughing
pretty
at
maximized and it looks fine to me.
Yeah.
Okay. So let's do this. Let's go.
I think it looks all right.
Let's go 22. 22. We do need 2 windows for this. 22.
All right, that'll do.
Yeah. I mean, that's it. I could do that, but that will look very awkward.
People say it's readable.
Everything will look very awkward. Let's try that. I mean, that is just too big. No? Tell me that's perfect.
It's off the screen. I mean, like
It
the
is.
Tanzu and the QR, but it's
Yeah, I can close this.
definitely.
We can only see slides, and then I'll need to switch to another window to do the coding part. Would you prefer
I think
that?
that'll be good.
Yeah, let's just do that.
Yeah.
Okay. All right. So let's keep that.
Thank you, everyone at home, for also helping with us solving that problem.
I changed the video quality to 720. Yeah, that will make a difference. Even like 1080p, if there is such a thing. Okay. Are we ready to start?
Yes.
Let's
Okay.
do it.
So my name is Gerhard Lazu. I'm a VMware staff engineer where I work on the messaging. Can't see left margin. Should I be concerned about that?
I see it. Maybe it's a delay from earlier when but I don't. Let's see.
Okay.
I'll let you know if something ends up not showing, but for the most part, it looks like it. I mean, it cuts off a tiny bit, like a tiny little smidgen of the left side of your screen, but not. I don't know if.
Yeah, but that's at the stream. You're fine. There's like a tiny little, yeah, I can see both sources and it looks fine. There's like 2 millimeters of stuff being cut off the left, so nothing that matters.
All right. So as I was saying, I work in the messaging and streaming group on Rabbitmq, and my Twitter handle, the bird, that's the giveaway. It's Gerhard Lazu. So there's some interesting things there if you want to check it out. So Tanzu Rabbitmq, it is a product, and it's a bit more confusing than that. There's actually a few products based on where you run. But the focus for today's discussion is the experience. It's the Rabbitmq experience. So whenever I say Tanzu Rabbitmq, I want you to think about a Rabbitmq experience. And the idea is that whether you are running Rabbitmq on-prem or on the public cloud, it should work the same. The experience should be the same. You should get the same thing. Everything should be the same. Whether you're a beginner or an expert, again, the experience should be the same. So beginners, they only need a certain amount of Rabbitmq-ness. And experts want to go deeper. So it should cater for both beginners and experts. And the idea is that if we have the same baseline, the same starting point, regardless where you run, we can have better conversations because we can try and figure out how you got in a certain state. But if we all have different starting points, it's really difficult to figure out what the delta is between what I'm seeing and what you're seeing. And while we have tools to make the experience as similar as possible, there's still some differences, but they are far smaller. And I'm thinking Kubernetes. So Kubernetes comes in very many different flavors. And I was reading some days ago, there are apparently 168 flavors of Kubernetes. And while they try to work the same, there will be some differences. Now that caveat aside, we can move on. So how do you start on-prem with Rabbitmq? And this is Tanzu Rabbitmq. So there are 2 steps. The first step is to apply some YAML, right? Because we all love applying some YAML. By the way, this discuss is a long discuss about how to apply YAML. That's a half joke there, but not really. So the first step is to apply the cluster operator. the cluster operator is something that runs in Kubernetes and manages, in this case, RabbitMQ clusters for you. So I'll go to the next step, and then we'll do both at the same time. And the second step is literally just deploy me a RabbitMQ cluster. And the easy RabbitMQ is really, really easy. So let's have a look at what that looks like. I'm going to get out of here. This was my other window that I shouldn't be using, but I am. So first of all, okay, config get contexts. Let's have a look. I need to source my env. Okay, config. So as you can see, I have two contexts. One is the on-prem one, and one is the public cloud. And RabbitMQ operator is just something that packages RabbitMQ for me. So if I apply this, it basically packages the command, just runs it for me, kubectl, the file name, applied. Because this already has been installed, there's nothing to do. But this is what you get when you run it against a Kubernetes. The next command is to run easy RabbitMQ. And all it does, it just configures a RabbitMQ cluster. Very, very simple. Let's have a look at what that RabbitMQ cluster looks like. So if we have a look at easy RabbitMQ YAML, it's literally this. API version, kind RabbitMQ cluster, it's easy, the name, and that's it. Everything here is optional. So I'm using the GCR mirror because of the Docker Hub limits that were introduced recently, and I'm specifying I want 3 nodes and certain resources to match my on-prem environment. So what does that give me? Well, it gives me a 3-node RabbitMQ cluster, and if I want to look at, let's say, the public face of RabbitMQ, which is always the management. So here, it's an optional node port service. I can look at the RabbitMQ management. It's all running locally. It's on-prem. It's a local host. It's a Linux host. So if I check that out, this is what it looks like. This is what I've deployed earlier. But by default, within a few minutes, this is what you get. 3-node cluster, RabbitMQ cluster. Fairly easy, fairly standard. There's nothing really interesting here other than you get the RabbitMQ cluster. Okay, so as a beginner, you look at the management, you have the management, you can click around, you can do things. As I said, nothing interesting. What about an expert? What if you really understand RabbitMQ and if you understand Erlang and you want to go deeper? Well, one of the things that the cluster operator does, well, wink, wink, PR, it will install a Grafana dashboard. And actually, it installs a few Grafana dashboards. And those dashboards integrate with RabbitMQ. And they allow to visualize certain metrics that RabbitMQ exposes. These are Prometheus metrics. It exposes them natively by default. You don't have to do anything. It allows you to have a look at them and understanding RabbitMQ slightly differently. So this is the same RabbitMQ Easy cluster that I had deployed there. Excuse the very large font size. But this is what it looks like. It's the overview. You can understand different things from RabbitMQ, and it goes on and on and on. There's like a lot of stuff here. I think the most interesting part are these eyes. And this is like a lot of information is captured here, where they explain what those metrics are. And they also link to documentation. So if you don't really know what these things are and you want to understand what's behind them and what they mean, this is a good place to look. And there's a whole Prometheus guide which explains these dashboards, what the colors mean, and a bunch of other things. So again, not very interesting if you have been using RabbitMQ, but as an expert, I think you'd be more interested in Erlang. And if we have a look at the metrics, yes, discard, I don't care about that. Let's have a look at Erlang. Again, same RabbitMQ node, cluster operator, Erlang memory allocators. I can have a look at what's happening from a memory perspective at a very deep level. So every node, if there's maybe, for example, some memory issues, it's all here. It allows an Erlang expert to understand what exactly is the problem with this node from an Erlang perspective. And that helps. So beginners, experts, on-prem, it kind of works. But what about the public cloud? So how do we take the same experience and how do we apply it to the public cloud? Well, just as I had before, let's see, use context. No, okay, config. And I think at this point, tell me if you're bored of typing because I can switch to something more exciting. Are people bored of watching me type? I'm looking at chat. Okay.
No, go ahead, please. Sorry, I had to get over to my mute.
Okay, so you need to continue typing.
We got some responses.
Okay, there is also some more interesting stuff, but I can keep it for later. Something ncurses based, K9s. Anybody familiar with that? You want to see some K9s in action?
Yeah, show some K9s. I saw K9 like 6 months or longer ago, so I'm sure it's changed a lot since last time I saw it.
So just a little bit of background. M is make. It's really cool. And in this repo, I have a make file which has a bunch of targets. Not all of them are documented here. But the one that I'm going to reuse is make K9s. And all it does, if K9s is not installed, it installs it, and then it runs it in headless mode. All that means is that it won't show me the help at the top. So this is an ncurses interface into the Kubernetes, which is running on-prem. And we can see the version 1.18.10. It's K3s. Ask me about that if you wanna know more about it. And we can see we have the 3 Rabbitmq server pods, and we also have perf test. This one is not that interesting, so let's ignore that for now. So K9s, and we talked about context. So I'm going to do CTX, so colon CTX for context, and I can see what my contexts are. So I can switch to my public cloud. Enter. And now I am on the public cloud. I'm going to filter for easy. This is the pods view. So I have 4 easy pods. 3 are the Rabbitmq servers, which is the easy cluster. And the 4th one is perf-test, which is a benchmarking tool that runs against the Rabbitmq cluster. It just simulates some load, easy load. So the thing which I wanted to show is that when I switch the context to public cloud, I do exactly the same thing. I basically apply the same YAML. So again, in K9s, I do colon dir YAML to open up my YAML directory. And I have a bunch of YAMLs here that I can apply. And it's basically this one, easy Rabbitmq. A for apply. And it configures another cluster on the public cloud, which I'm targeting here, using kubectl, all that stuff behind the scenes. Okay. So we have the same Rabbitmq cluster on the public cloud. What does it look like? I'm wondering. Well, it looks very similar to what I had locally. The only difference is that I have an FQDN, which is set ahead of time, Tanzu Tuesdays. This is how I know it's legit, right? I am from rabbitmq.com because I've controlled the Rabbitmq domain name, maybe. Tanzu Tuesdays.rabbitmq.com. It points to a public IP address. It's a load balancer. There's a 3rd optional step I can show if you want. Would you be interested in that? Okay, I'll keep going. I will be watching the chat, so if you have any questions or anybody wants to ask me anything, go ahead. I don't mind stopping. Okay, so again, same approach, same apply, just a different target, and it gives me the same 3-node cluster. Same version, same Erlang, same everything. I mean, maybe this is not that interesting, I suppose, because we are used to containers by now. But I think the interesting part is how little it took us to declare a Rabbitmq cluster, just a few lines. So we don't have to worry about secrets and clustering and a bunch of other things, balancing and stopping and starting. And there's so many things that the cluster operator handles behind the scenes. Okay, so we have easy Rabbitmq. It's the same cluster operator. I hope you're appreciating, if you can see the fireworks, that's actually what took me the most time, in this presentation, the fireworks in console. If you want to
I'm
learn
well
more.
They're great. I like them.
Cool. So cluster operator, it's RabbitMQ Cluster is the easy way. GitHub.com, RabbitMQ is the org, cluster operator. You can have a look at it, see what else it does, see what else is coming. Okay. This is interesting. However, what about the Tanzu RabbitMQ part? Right, you all thought that this is Tanzu RabbitMQ. So where does that come in? Tanzu RabbitMQ is a commercial distribution of RabbitMQ. So it's the RabbitMQ that you know, just better. It has a bunch of commercial features. It's production ready by default. It has extended support, and you know exactly when it's going to ship because it has date-based releases, a bit like Ubuntu. Ubuntu is like that. Other software as well, but I think Ubuntu is the most popular one. And it also has 24/7 support, which is backed by us. So if first line, second line, it will get escalated if it's something more complicated. So if you have Tanzu RabbitMQ, which is, as I said, it's a commercial version of RabbitMQ, then who knows, maybe one day, if you have a problem, I will be the one helping you with the RabbitMQ cluster. It's possible. So how do you get a Tanzu RabbitMQ? And whether it's on-prem or on the public cloud, how do you get it? So what we're going to do now, it's a bit of a roller coaster, not really, because you know what's going to happen, but it's fun. We're going to do the in-place rollout. So we're going to apply Tanzu RabbitMQ twice, and we're going to upgrade the open source cluster. Cool. Thank you, Java Grunt. I'm digging them too. The slides, that's what he was referring to. Okay, so we have the public cloud here. Let's apply the Tanzu RabbitMQ then while we wait for that to happen. It's the same cluster that's getting configured. We are switching to the pods. We will filter for easy. And this will be slowly rolled one by one. You can see one is already terminating, so it's an in-place, stateful set. Last one starts with last one and goes through them one by one. As that's happening, let's do the same thing. Let's do make canines again. Let's switch the context. Let's run the same thing on-prem. That's already targeted. That's perfect. Directory YAML. I'm just going to apply exactly the same thing twice. So apply, pods, easy RabbitMQ. This is running on-prem. It's going to start, so they both get upgraded at the same time. Okay, one is already booting. It will continue with the rest. That's okay. Again, nothing out of the ordinary. If we go to RabbitMQ management, this is the local one. I think this one will be more interesting to watch. So one is already coming up. If I refresh, yep, it's already up. And I'll keep refreshing this because the thing which I'm looking for, we'll see it in a minute, it's this thing at the top. That's how you know that this is VMware Tanzu. There's a load balancing front. Requests are getting round robins. One of the nodes is already VMware Tanzu. And this request was basically serviced by that node, which is the third one. Now the second one is being taken down. So one by one, rolling upgrade in place from free to open source. And by the way, you can also go back. So there's no lock-in here. If you don't like it, trust me, you will. But if you don't like it, you can go back. No problems. Okay. For now, fully compatible. What happens later, we'll see. Okay. And if we go locally, the same thing is happening. We need to refresh this a few times. There you go. This was serviced by a node that is VMware Tanzu. Second one, it will go through them. Okay, so we'll let it go through them one by one. Coming back to the slides. How do you know? I think I've already answered that. There's other ways, but I think this is the easiest one, especially since we're looking at RabbitMQ management. How does it help? So you got Tanzu RabbitMQ. It looks the same. Why would you get it in the first place? Besides support, besides a bunch of other things. I think one of the most interesting selling points of Tanzu RabbitMQ is that it compresses the traffic that's exchanged between nodes. And what that means, and again, we'll see this in a minute, your nodes will be transferring 93.75 less cross-zone traffic. So with every packet that doesn't transfer cross zones, it's basically money in your pocket. So do people roughly know about Ingress and Egress between cross zones on the public cloud? Does anybody have that problem? It's killing you, the traffic between zones. Okay, well, think about that, and if not, it's not a problem. But some of our users that have large workloads, they're pushing a lot of messages through Rabbitmq, and for redundancy reasons, availability reasons, they are spreading their clusters across availability zones. Obviously, they replicate messages so that if one node goes down, they can continue consuming messages and publishing messages as if nothing happened. So the cluster's still available, it's still there, no problems. Whenever a gigabit or a gigabyte crosses the boundary between zones, on the public cloud, you tend to pay 1 cent for every gigabyte. And on some public clouds, you pay 1 cent when it exits and 1 cent when it enters. So you may be paying up to 2 cents per gigabyte. These add up, and we'll see that in a minute. So we have the Grafana here that runs, it's already set up. We have the Erlang distribution. This is another cluster. It's called billion compressed. And the reason why it's called billion compressed is because it's pushing 1 billion messages per day, which is roughly 11,000 and something per second. The messages are about 5 kilobytes. They're JSON, so we're trying to simulate random data, what users may use Rabbitmq for. This is trying to be as real world as possible. There's decent randomness built in. We can go over that in a minute if you're interested in that. And it's compressed because by default, when you deploy Tanzu Rabbitmq, it's using compression between nodes. So 1 billion messages per day, which are replicated across all 3 nodes, means that one node is the leader and 2 other nodes are the followers. So what it means is that in this case, Rabbitmq1, the queue that runs on Rabbitmq1 is the leader queue, and it has to replicate those messages to Rabbitmq0 and Rabbitmq2. So it has to replicate to both other nodes. And it's pushing roughly 3.87. So let's round it up. Let's say it's 4 megabytes per second. Okay? Same workload, same config, uncompressed. 64 megabytes per second. Same throughput, same everything. The only thing different is that we're using compression. It does use more CPU, right? But CPU is fixed. So once you pay for your cores, that's it. You either use them or don't use them, but there's no price based on how many cycles you're using on those cores. With bandwidth, it's slightly different. So in this case, we are trading off CPU for saving bandwidth because you're using compression. Okay. So what does that mean? So 4 divided by 64. Did my screen froze? No, something else froze. Okay, that's a bit weird. My screen has gone all weird. Okay. Oh, there you go. Whatever that was, it fixed itself. Okay, so 4 by 64, you can trust me, it's 0.0635, roughly. That's what it gives you. So the difference is 93.75%, 625, not 635. Right, coming back to the slide. So that's the first big advantage. It saves you a lot of money. And I was going to show this using that, but for some reason it doesn't like, maybe I think it's this small screen resolution. If you're transferring, let's say, 1 billion messages per second every day for a month straight, then by the way, you could go more. So it's like an average. You can have peaks and you can have drops. It's not a problem. But on average, if you're pushing every day 1 billion messages per second, the saving per node is about $1,700. That's per node if you're only paying for Egress, not Ingress. The savings mount up. You could be saving a lot of money just with this feature alone. The other thing is about, the other thing that it helps you with, it has this thing called multi-cloud schema replication. So what it means is that you have an upstream, which could be your primary cluster, and then you have one or more downstreams. And those are your hot standbys, if you wish. Anything happening on the on the primary gets automatically synchronized to the secondary, so that if for whatever reason the public cloud that you're using goes away, you have a downstream that has been replicating the metadata from the upstream, and you can fail over. And we'll take a look at that as well. So how about we configure this next, upstream and downstream? By the way, this is going to take about 10-15 minutes. Some typing is involved. Is this interesting, or do we skip this? I'm easy. What are people interested in?
I say do it. Go for it.
Okay. Cool. So public cloud. If we go here, we have the Tanzu Tuesdays. So let's configure this as the upstream. This is the easy cluster, remember. Okay, if we go in K9s, this is the easy cluster. This is the public cloud. Yep, we'll open a shell. Oh, how did I do that? Okay, let me get out. Let me go in the easy cluster. Let me filter by easy. That's the one. So one of the shortcuts that K9s has is S for shell. So I think if I press, that's the one. That shows me all the shortcuts. Kill, logs, edit, describe, a bunch of things. But the thing which I'm interested in is shell. So I can open a shell on the Rabbitmq node. Okay. And let's see, where do I was expecting to have more screen space. I'll need to open another tab. Okay. And then I have YAML, and there's the Tanzu Rabbitmq upstream. I have some things to copy from here. So the first thing is to put it in upstream mode. The reason why these commands, you know what, I'm going to run this and we can talk about it. So schema replication mode upstream. Things are a bit laggy. Okay, I think, why didn't this get applied? Rabbitmq. So there is a plugin that needs to be enabled, Rabbitmq plugins list. Okay. So schema definition sync has not been enabled. I'm wondering why. I did apply the easy Rabbitmq. I did apply the Tanzu one. Oh, I think I know why. I did not apply the upstream and the downstream one. Okay, that's not a problem. The only thing which I really need to do is just apply this plugin, enable this plugin. So let me enable it in situ. There was a config, which is basically this file that I had to apply to the cluster that would just enable this plugin. So that's okay. Rabbitmq plugins enable. Rabbitmq schema definition sync. Okay. Right. So now, where is it? That's not what I wanted. Here at the top. Yep. So it's the upstream. That's the one. Okay, so now this is configured to be the upstream. I need to add a vhost. What's next? This one. I need to set up a replication user. Okay. And then I need to configure. Yes. That's what we have currently. And as this will mature, I was looking at the chat, all the best configuration work is done from inside the shell, inside a container on Kubernetes. I think that is true when some of the concepts aren't fully integrated. Same as with YAML, right? There's like a lot of YAML. But as the whole integration will mature, the cluster operator, I expect, to be handling these concerns, setting upstream, setting downstreams, the best it can, especially if it's multi-cloud aware. Right now, that doesn't happen because how do you fail over? When do you fail over? Stuff like that. Once everything is there's more metrics, there's more observability, so we can understand what happens in different clusters and what events should trigger, for example, a promotion. Do you even have a secondary cluster that you want to mirror and replicate? All those things, as they mature, I'm sure these things will catch up and we won't need to run these shell commands. But today, we still do. Okay, so we've set the user, and now we can just watch the replication status. So let's see, upstream, recover, it will eventually go into syncing, and that's when we know that it's done. Every 2 seconds. You can also look at the logs. That's like another way of doing it. Okay. Syncing. That's it. That's what we're waiting for, state syncing. And now the upstream is configured. It's ready to sync. So the downstreams, by the way, are the ones that pull from the upstreams, but the upstreams need to be ready to wait for downstreams to connect to them. So that's what we just did here. And if you have a look at the logs, we can see schema definition sync, upstream worker is ready to sync. So that's all set up. Okay. Now that we have this on the upstream, we need to do the same thing on the downstream. So again, let's take, this is the on-prem, this is our secondary cluster, shell, and this is slightly different. I'm going to open a new window, a new tab, this is the downstream that we're configuring. So first of all, we're going to set the REST schema, but I think the first thing is enable the plugin, Rabbitmq. Plugins, enable, it was the schema. Where was it? No, yeah, isn't that easier? Let's list the plugins, this one. Thank you, plugins, enable, that's the plugin. Okay. Sync has been enabled. Let's set the downstream mode. Let's configure the upstream. In this case, Tanzu Tuesdays. I'm just connecting to the load balancer with the username and the password that I configured. This is another thing, for example, that should be automated so that we don't even know what those users are and what the passwords are. That would be a lot more secure. And then let's just watch this replication until it's all set up. Downstream syncing. Yeah, it's already configured. Okay. So on the upstream, Tanzu Tuesdays, let's declare a new queue. Let's say, let's call this the business queue. How about that? Very important queue. All business transactions go through it. So we have declared it on Tanzu Tuesdays. And because we have schema replication set up, login failed. Yes. Okay. The reason why the login fails is because when it's synchronized, whatever was on the upstream cluster, it synchronized all the users, everything. So queues, users, all the objects. So the login which I had stopped working because I have a new user now. Okay, so how do I solve that problem? On the upstream, if I have a look in the secrets, there's the easy default user, X for decode, default path, default user, close, log out, sure. Default user. So this is, I'm locally connecting with credentials from the upstream because they've been synchronized. No, I don't care about that. What about the queues? Our business queues there. How about we create one more just to make sure this works? It wasn't 1 time lucky, it's 2 times lucky. So let's call this the Tanzu Tuesdays queue. And let's make it of type quorum. It's another queue type. Name is required. Right. Tanzu Tuesdays quorum queue at queue. So this is a replicated queue by default. It has replicas on both Rabbitmq2 and Rabbitmq1. And the same queue is here. So same queue type, quorum. Here it is. Okay. So everything's fine. Everything is chugging along. And then we lose the primary. The public cloud goes away. Well, I can't delete the public cloud in this case. What I can do is delete this Rabbitmq cluster. So Rabbitmq clusters, it's a CRD. That's how we've been configuring all these clusters. So if I go and list all objects which are of type Rabbitmq cluster, I can just delete my easy one. Delete the cluster, and it's gone. You see it's going away. All the pods one by one, and it's gone. So there's no more primary. What happens with the secondary? The hot standby. So this one's gone. I can't connect to it anymore. Done. If I was to have a look at the Erlang distribution, I can see that there's no connections. There's no metrics. Properly gone. Okay. Well, the hot standby is still here. The secondary is still here. It still works. It's on-prem. Okay. So on-prem save the day? I don't know. Let's see about that. We need to promote it first to be the new primary, right? Because like backups, unless you restore them, how do you know they actually work? So let's do that. Anybody interested to see how that works? I'll take that as a yes. Okay. How do we do that? Well, we had all the instructions here to promote a primary. So first of all, we need to disable replication because there's nothing to replicate from. So let's do that. This, by the way, is, I'll just get out of here. This is my on-prem. We can see that from the top. This is the on-prem one. So this is easy. So let's disable replication. Okay. There's nothing to replicate from, right? We need to create a replication vhost. Okay, let's do that. We need to create the replication user so that other downstreams can connect to this. Okay, it already exists. There's nothing to do. Okay, and configure upstream. So it needs to know where to replicate from. It's from itself, basically. This is easy Rabbitmq client, so let's do that as well. It's all being configured. And let's put it now into upstream mode. So it's no longer downstream, it's upstream. Okay, and we can re-enable schema replication. What about that watch? Do we still have it here? Yes, we do. We still have it here. Mode is upstream, the cluster syncing. That's it. This is our new primary. It's our upstream. So any downstreams, they can now connect to this cluster and replicate all the schema from it. Any publishers, consumers? Well, that's a different story. How do you change them? How do you fail over? I suppose it depends where they run and how they run and what failover mechanisms you have. But this is how you would promote a Rabbitmq cluster from a hot standby to a primary. That's how this bit works. Okay. And that brings us to some more funky animations, explosions. It's not fireworks, it's called explosions. Production Rabbitmq the right way, but also the easy way. You just define the cluster. I think that's like another thing which I wanted to show you, like what the difference is. So let's have a look at the easy Rabbitmq, which this is what it looks like. And this is the Tanzu Rabbitmq. So if I div this, and if I div this, the only difference is really the image. And we're pulling it from a VMware Tanzu registry. It's currently the dev registry, but it's going to be the final one. And that's it. Otherwise, same config, works the same. A couple of extras, but very, very familiar. And now the question to the audience is, what would make it even better for you? So you've seen Tanzu Rabbitmq, the first version. What about the next version? What should we do to make it even better? Based on what I'm seeing is you don't want to be executing any commands anywhere in a container in Kubernetes. Point taken. What else? By the way, this is the end of the presentation. There's nothing else.
Okay, no problem. I thought you were asking the audience for a feedback, so I was like, oh, okay. But no, this is great. This is quite wonderful, and I'm glad that you added that extra part in, just because I think that was important. So, yeah, how'd that feel?
For me?
Yeah,
it felt really good. I enjoyed myself.
Yeah,
as I do. Yeah. How about you? How did it feel for you? What's the impression? I can dig.
Yeah, it felt good for me. Sorry, my wife just came home and she was teaching, and so it's all online over here. So that's why I was a little confused at the end. Like I said, I thought you were asking, but no, I greatly enjoyed it, and I know that this is some of the most interaction on the side that we've had in a great while, in a good way. So so yeah, it's you nailed it, crushed it.
I thought this was awesome. And then just everything that you're showing, plus also pairing with the fact that everything that you were doing slide wise and typing wise was all in the terminal, which made it even more unique.
Yeah. Are you using a custom, have you written your own slide tool there, or are you using something that's open source and available to others that want to nerd out?
Yeah, I'm using something which is open source. It's called Present. So let's have a look. Let's have a look at the slides, right? So the slides are YAML, as you would think, right? I mean, it's all here. Okay, all of it, all 158 lines of them. This is the end. And there's a make file which puts everything together. Okay, make file which includes other make files. Yeah, it's. I'm very happy with that. Very happy about that. It also configures all the hosts, by the way. So the on-prem will set up like this. Maybe less interesting, but you asked about slides, right? So let's jump into slides. Okay, so this is the URL, github.com. So let's click on that. VMware present, and present read the docs.io. That's the URL. Pip install present. Pip 3 install present in my case, because Python 3, right? But that's it. You can also do some codes and some pre-recorded code block. I didn't have any of that. Some interesting effects. It's all there. Have a look. What else would you like to know?
How did you do the fireworks?
How did I do the fireworks? Okay, so you want to know all the secrets? I'll tell you.
I guess we could be asking rabbit questions, but I think we're all excited.
If you want. So this is how I did explosions. Right. Line 144, effect explosions. And fireworks. This is how you do fireworks. It took me a while to figure this out and to know where to use them. That was the hard part. What works? Right. Because, for example, there is... What other effects are there? Hang on, let me have a look at the make file, which will tell me. So fireworks, explosions, stars. How about that? Let's change it for stars and let's see what happens. Let's have a bit of fun. Okay. Where is it? Cluster on-prem, beginners, experts. Look at that. Now we have stars. Nice. That's wonderful, isn't it? Okay. What else do you want to try? Anything else? Stars, matrix, plasma. These are basically full screen. So if I go plasma, if I do that, plasma, there you go. That's what I wanted to do. And let me go to that slide. There you go. That's what that looks like.
Oh my gosh.
Whoa.
Crazy, right?
I love it.
I wonder if you can change the letters to spell it like Kubernetes or Rabbit or something.
I was convinced you were going to say that. Okay, yeah, we should, for sure. PR?
That's so cool. Maybe.
So one thing I was going to mention that I really appreciate was that the operator isn't trying to do everything and doing everything badly like I see a lot of operators doing. Mm-hmm. So I think actually the fact that you do exec in and kind of run some commands to do some of the steps is actually a good sign that you're sort of saying, well, these are the things we know we can do well in the operator, and these are the things that we know we can't. So do them the way you're used to doing them on a standard Linux kind of environment. And then as we bring those features in, obviously you'll be able to stop doing those. So while it does look weird at first to see you running random commands in a container, I think it's actually a good sign.
Yeah, I think that's like baby steps, I suppose.
Right.
I can see how something like custom CRDs, which are targeted for replication, for example, would make things go a long way. Especially as you could see me type, for example, use names and passwords and create users and do all of that. So maybe if we had a custom CRD which handled replication, it would know how to create all the secrets, where to get them from, how to get them from, which authentication mechanism to integrate with, and also multi-cloud. Because I had to do one thing on this side, another thing or very similar thing on the other side. But really, if I configure replication in one place, maybe there's a way, and I don't know how, to do a multi-cloud Kubernetes based something, I don't know. Right. I don't even know how that thing would be called, but basically an operator that would be aware of the fact that there are multi-clouds and they all are part of the same one thing. Because they need to somehow to talk between one another, right?
Yeah,
and
so there's work being done on like federation in Kubernetes to do that sort of thing. And there's a lot of talk whether it should be like one big cluster that spans clouds, or whether it should be multiple clusters that talk to each other to do that sort of communication. So then figuring out how to do an operator on top of all of that before it's even figured out is quite a daunting task.
Yeah, I can see how that would be the case. There's also a possibility, has been even like an experiment, where we declare Rabbitmq objects via the Kubernetes API. So a queue, for example, or user, you declare it via the Kubernetes API, not just a Rabbitmq cluster.
Yeah.
So then if you declare that in the world of Kubernetes and you have synchronization happening between multiple Kubernetes clusters, then if my on-prem is synchronized with the public cloud, in my case, then whatever I'm defining for Rabbitmq on the public cloud is automatically replicated. This is at Kubernetes level to on-prem.
Right.
And then maybe I don't even need replication, schema replication in the context of Rabbitmq, maybe. But that's like a tangent, I suppose. It's another way of maybe slicing it. So you know how good developers copy and great developers paste? You know that saying? Okay. So in the same context, the best developers delete. So let's do that. Let's delete some clusters because they're costing money. Let's go to public cloud, delete. That was it. And then everything else will disappear. I think I can show you the same thing with deployments. Delete. Yes, delete. There we go. Everything's been deleted. So what else would you like to see on-prem, if anything? Because the public cloud is now clear.
I don't have anything specific. This is just really cool.
I'm glad. Yeah. I suppose one thing which I have for all of you is how do we standardize on certain things, such as, for example, PVC classes, like storage classes? Because, and that's just like one example. It's a very specific example, but based on where you're getting your Kubernetes from, SSDs may mean different things, and you may not even have the option of specifying SSD drives.
Right.
Does anyone know how to solve that problem?
So I don't think there's a good way to solve that problem other than hope they have a default and then provide a way to specify a specific storage class and then leave it up to them to determine if they need to pick something specific.
Mm-hmm.
I guess you could try and precede it with, well, we know what the default GKE ones are. We know what the defaults Amazon ones are. So we could put those in as options, but at the same time, anyone using those should probably know what their options are and what's best to use in their situation anyway. So I think just like hope they have a default storage class to start with. And then, I mean, I guess you could also allow the option for like an empty dir or something, so they don't even need PVCs for like test scenarios. But otherwise, you know, default storage class, unless they specify otherwise, tends to be the way to go. And then hope that they don't also need like annotations and labels and other weird stuff to be even more specific.
So there is, I can see like some sort of a contradiction, but before I do that, let me maybe change the pulse. There's another view, by the way. I'll just keep it interesting while I'm screen sharing. Okay, so users, when they want to consume a service, they say the service should choose like production ready. I want a production ready service. And from a perspective of RabbitMQ, we know what a decent production ready looks like. Obviously, everybody's production is different and users' needs are different, but they want a good starting point, like a good baseline. In that baseline, it is important that we have SSD drives, because replicated queues like quorum queues, for example, especially when you have many of them, they're very sensitive to disk I/O. So they can perform terribly if you have, for like random I/O, if you have spinning disks. And on GKE, that's what you get by default. So to get SSDs by default, based on the cloud provider, you need to do something else. It's always something different. And while, yes, we could cater for some, like you said, GKE, EKS, AKS, I assume. TKG is very interesting. Maybe we don't want to open that can of worms right now, because you may not even know, right? You don't even get the option in that case. But then this baseline starts diverging. And while we'd recommend SSDs, and while we'd recommend quorum queues and a bunch of other things, but while we hey, Gabriele. I was looking at chat. So while they diverge, they expect a production ready to begin with. So how do we deliver on that? One idea is for the cluster operator to maybe kind of try and figure out which Kubernetes it's running on. And if it's GKE, it knows it's SSD. And if it knows something else, so that it handles, it has better defaults for a production ready RabbitMQ, especially if you're using Tanzu RabbitMQ. I think, at least from my perspective, that seems to be like the easiest approach.
Yeah, I think that seems fair. That, you know, it's not fair to ask Rabbit, the people writing the operator, to know everything about everyone's clusters, but it is fair to expect the person who operates the cluster for the organization to know that stuff. So having some kind of like profiles CRD that lets the operator input, like, here's our 3 profiles that a user can choose from. And that will include things like, you know, the production profile, which they'll specify the storage class to use for SSDs, and maybe affinity for running on a particular labeled pod or a particularly labeled node or stuff like that. I think that's probably a fair way to do it, as long as obviously if someone just asks for a rabbit, there should be a very, very good chance that they'll get something that works reasonably well, even if not production ready, without anyone setting any of those things. Because obviously that first use case, that first use experience is like super important. So you kind of have that battle between it just works and also it needs to work in production without, someone, doing a PhD thesis in how to run RabbitMq in production, because the operator should be that PhD thesis, right?
Yeah, that's right. That's right. Because, that's right. Like one thing, for example, which was very obvious when I did, for example, the Easy cluster, by default, RabbitMq, the operator provisions 10 gigs. Okay, and even if you specify SSDs, you're limited in terms of throughput and IOPS, like bandwidth and IOPS, because of the size. And then RabbitMq performs poorly because of the disk, but you don't know, because you don't even know what you got and you don't know what the limits are. We have seen that story so many times. And they say, well, tell me what disks I need to get. And I say, well, tell me what disks you have, because I don't know what you have. I mean, you need SSDs. Makes a big difference, especially for certain workloads. But anyways, Robert Gogolok, what does he say? Clusters can go down randomly for whatever reasons. There is some stuff in the stateful sets Kate's native stuff can fix too, but there are sometimes situations where special RabbitMq might be necessary and that could be automated. Is it something the operator will take care of? I think, for example, the Zalando Postgre is capable of this. Okay. It's more some kind that should run per instance and the operator should not be aware of. I see. Okay. Let me think about that. There's, again, so many ways to slice it. So I think, first of all, you need to understand what is happening in a Rabbit, for sure. Metrics is one good way, but also events, because RabbitMq, by the way, emits events. We do expose very good metrics. Did I delete everything? Not quite everything. Okay, we have RabbitMq management. This is running locally. Okay, this is running locally. So for example, let's have a look at the overview. RabbitMq, I think that's like the first step. So RabbitMq overview. So in this case, let me zoom out maybe the last 3 hours. Let me zoom in. Okay, so have a look here. This is the memory available before publishers get blocked. And you can see how this is slowly decreasing. There was like another one here. So eventually, if this gets to 0, publishers will be blocked. Same thing for disk. So first of all, you need to, in a way, expose this and have some trends to see what as this happens. Would you provision more memory? Well, not really, because Erlang, the runtime is Erlang. It will try to use as much memory as possible. So in this case, for example, RabbitMq overview, Erlang allocators. So let's have a look at that. Let's have a look at the Erlang memory allocators. Let's have a look at the last 3 hours. So in this case, what's been happening with this node? You can see that the used memory, it's been going up slightly, but not that much really. So we went from about 100 meg to something. Again, this is something which we need to understand, I suppose, expose, and then something needs to take some sort of action based on these metrics. Would it be the operator? I don't know. I don't think we want to put... Yes, Paul.
Yeah, I was going to say, ideally, you'd want to use like the Kubernetes, like horizontal or vertical pod autoscalers, and just have the operator configure those, assuming that you can get all the configuration needed in the like deployment manifest and config maps to, stand a new node up, attach it to the cluster, without having to do any extra orchestration from the operator.
Okay, but what I'm trying to get to is that adding more memory is not going to fix this specific problem, because Erlang will try to use as much memory as it needs, up to a point. It's a bit like Linux, right? It'll try to cache, but in this case, it's you can see it's allocated unused. So about 30 megabytes out of 136, it's just holding on to it because it thinks, well, if I need some more memory, I won't go to the kernel. Now, this requires some very specific knowledge of how the runtime works.
Right.
So,
I see what you're saying. Yeah.
So in this case, I don't think the operator would need to do anything about this, but maybe something else, maybe some sort of a custom thing running, custom operator, I don't know. Or something that like an optimizer for Rabbitmq, maybe, that would try and figure out based on these they will have like a set of rules, right? Will I have maybe some alerts? And when an alert triggers, it can take some action based on what's triggering. But for that, you need good metrics so that you can understand. And then you need to put all that logic of what you would do as an expert and have that operator do that. Does it answer your question, Robert? It's complicated. It really is, because, and it's all use case specific. In this case,
I would assume the basic stuff like pod failure and stuff just gets handled by the stateful sets / deployments, and the operator doesn't even have to worry about it, right?
That's right. So in this case, if we delete it, but if that's a stateful set, right? I think it's the replica controller or replica, whatever it's called, replica set, right? That replica set, we only have one. Replica sets is for apps or like deployments. Yeah, stateful sets, that's the one. Yeah, it knows 2 out of 3. Yeah, that's the one that takes action in this case. It's not even the operator. But the operator is aware of like different Rabbitmq concerns, I suppose, based on what you configure on the operator. So any of those changes, it propagates to all the things. Mm-hmm.
Awesome. Well, look, I think we've been going for quite some time. So unless there's anything else pressing in the questions or anything, maybe it's a good time to wrap things up. Yeah, I see Robert just replied saying that, I think you gave him some interesting insight. Mm-hmm. So that's good.
Typically, by the way, when things fall over, it's your memory. That's why I mentioned memory. TLDR is give your pod more memory, a bit like extra headroom compared to Rabbitmq, because when Rabbitmq's depression keeps going up, if it hits that ceiling, it will be OM killed. But make sure that Rabbitmq has some headroom between its limit and the pod limit. And that's something, for example, the operator does recently. It adds extra headroom between what the pod gets and what Rabbitmq gets.
Mm-hmm. Yeah, so that's interesting, like very domain-specific knowledge that everyone that runs Rabbit should be aware of. But if the operator is aware of it, then they don't need to be the ones configuring it. Yeah.
There's actually a TGIR. TGIR is like TJK, but for Rabbitmq, TJK being the Kubernetes. So roughly every month we put one out. The next one is on how to monitor Rabbitmq, where we talk about all those dashboards. And the example that we give there is based on how the Rabbitmq monitoring is configured. If you have many queues and many connections, that will use up more memory, but also more memory for metrics in the default config. Over time, those metrics, because Rabbitmq stores them internally, it will use more and more memory. So in 24 hours, it may just fall over because you have too many objects. Again, very specific. We're trying to optimize that. And there's we'll talk about in the TGIR, how to go about it, what to expect. But if you have 25,000 processes running somewhere, you can expect that each of them will use 100 kilobytes, 200 kilobytes, and they add up because you have 25,000 of those.
Well, I guess next time we have you on, we can talk about how we've solved that problem.
Sure.
Cool. All right. Well, let's wrap things up. Tiffany, Bob, any last words? Bob, I know you've got family have arrived home and stuff, so you can just nod and shake if that's all you're capable of doing.
I'm good on questions.
Cool. All right. Well, thank you so much, Gerhard, for coming on. This was really fun, both from a Rabbit perspective, but also seeing the really cool way you did the slides in the console and everything. And I'm sure I'll be poking around at that Git repo. I already bookmarked it. And I would bet that knowing Deshaun, he'll probably be doing the same.
I'm glad. This was fun. I enjoyed it. Looking forward to the next one.
Yeah.
Thank you.
Yeah. Cool.
Yeah, thank you.
All right.
Gerhard.
Well,
That was
let's. Oh, Bob spoke.
I know we're doing dual work from home stuff right now, but she stopped talking, so now I can talk real quick. Gerhard, thank you. That was great.
You got dueling Zooms happening or something.
It's my turn. Stop. Wait.
All right. See you later.